Hello, this is Sebastian Lerich from the CloudScale project. In this video I'm going to show you how to use the CloudScale Analyzer for an analysis. As an input to the analyzer, we are going to use the ScaleDL model created in the earlier Screencast episodes. You see that I still have this model inside my workspace in Eclipse. Furthermore, I completed it by some information I left out in the previous screencast. For instance, I completed the allocation diagram. Now it includes all the assemblies you can find in the system. You find the complete model on the CloudScale webpage or in our SVN repository. To execute an analysis, we first have to set up an analysis run that uses this model here as an input. Afterwards, we can start the analysis. So let's continue with setting up our run configuration. Therefore, we have to go to the run configurations of Eclipse and double-click the SimuBench entry. We are provided with the default run configuration. I'd like to first adapt the default name, new configuration, to a more suitable one. So let's name it analysis minus TPC-W and apply. Furthermore, we see some error messages. First of all, the allocation is missing. So we have to specify the allocation file in this field here. For this, we go on Workspace and select the allocation file from our project. The next message tells us that also the usage file is missing. Therefore, we also select the usage file from our project. We confirm by apply and see now a new message telling us that under the simulation tab, the sensor framework, for the sensor framework, the data source is missing. So we go to the simulation tab, identify the sensor framework part, and press the browse button to specify a data source. So a data source is responsible for storing the simulation data. We don't want to store our simulation data in the data folder we already use for the measurements. Therefore, we add a new data source. From this list, we now select a memory data source, which stores the simulation data directly in the main memory. As we only plan to run a short simulation, that's fine. We confirm by finish. Finally, we select our memory data source and confirm by OK. We apply and see that we are left with no error messages anymore. However, I'd like to modify some default parameters of the simulation tab. First of all, I want to give our experiment a more suitable name. For that, I just use analysis minus TPC-W minus run and apply. Furthermore, I'd like to modify the stop conditions of our simulation. I don't like to have a limit on the simulation time, so I set it to -1, which means we don't limit the simulation time. However, I'd like to use the maximum measurement count and I'd like to decrease it from 10,000 to 1,000, because for the purpose of the screencast, that's long enough. I'm now finished with specifying my run configuration and start the analysis. To start the analysis, I press the run button. We see that the workflow engine starts the analysis and the analysis runs through. The workflow engine already completed its task, therefore we can now inspect the simulation results. For that, we go to the experiments view, reload the view, and see that our memory data source appears. We expand this entry and now see that our analysis TPC-W run also appears. We expand this run as well and also expand the experiment runs. Here we now see the simulation that just happened some minutes ago. We expand this results and see several measurements taken for our system. Usually it's reasonable to investigate the total response time from the viewpoint of the usage scenario. So we scroll down to go to the response time of home interaction usage scenario and double click on this entry. Here we can again select a response time series. The diagram shows a similar distribution as we got for our measurements. We can check that by loading the measurement data in addition to the simulation data to this diagram. For that, we scroll up, open our file data source again, and go to the measurement. We choose the measurement for the print hello operation and drag and drop it now to the graph shown. Now see that the measurement data is in addition shown to our simulation data. We also observe that the distribution measured is quite similar to the one we saw for our simulation. Could also zoom into the shown data to confirm that even visually even more. Why is the response time so similar for the total response time of the usage scenario than for the measured one for the method for printing hello? Well, the reason for that is that we so far only modeled demand for this method. So when we would add the response time measurements for print hello, we simulated in addition now as a third item to this graph, we would see that they are completely the same as for the total response time of the usage scenario. Therefore, the response time for the usage scenario currently equals the response time of the method for printing hello. We can now further inspect other taken simulation data. For instance, we could have a look at the demanded time at the application server, for instance in the form of a time series. We see that all the time spent in the system, if we compare it to the previous graph, was on the application server. We could also have a look at the utilization of the CPU, as we used the CPU within our print hello operation. So let's open the utilization of the application server. Let us use a J-free chart utilization over time. And let us modify this graph a bit. We see that the CPU was utilized over the time completely. The reason for that is that we continuously had users approaching the system. And they don't had any waiting time. You can confirm that by again opening the utilization of the application server and having a look at the utilization pie chart. We see that the CPU was all the time busy with one job. That corresponds to what we have modeled. We modeled a system where users always go to the homepage, which only shows the greeting, hello unknown user, based on the print hello operation, has no waiting time and immediately does the same thing again. Therefore, the CPU is utilized to 100% by always one job. We only have one user in the system. It's not possible that we have more than one job at a time in the current model. In summary, we can now use our model to simulate it and identify performance and scalability properties. In this screencast episode, you have learned how to conduct an analysis with our CloudScale Analyser, which was a relatively simple analysis for the time being. In the next episode, you will see how to use the CloudScale Analyser for identifying scalability problems in a more complex analysis scenario. Thanks for watching.